Hey guys, welcome back to the install for this Linux Gentoo installation on a Raspberry Pi. The installation is taking a little bit longer than expected, so I am going to end up splitting this into two parts. So in the first part, if you did not watch that, I will put a link in this video's description. I recommend you check that out first, or at least skim through it to know what's going on. In the first part, we prepared the SD card, got all the files copied over it, and then we put it in the Raspberry Pi, started the Raspberry Pi up, and got the SSH session working. In this video, we will log into the Raspberry Pi through SSH and do the actual emerge, install the software, get the settings all set up, and then get everything else ready to show off the Gentoo installation on a Raspberry Pi. So with that, here is the part 2 video. I've got the screen capture restarted. So we will SSH in now. SSH root at 192.168.3.105. Oh, I've connected this before. Just a minute, I need to clear out. That's one thing I forgot to do. If you've connected to a device before and you have IP addresses remaining, or if you have, so when you initially connect to one of these devices, it will kind of remember it, and if the ID of the device changes, like the SSH host key, you will get that error. So I forgot to change that. So okay, we're logged in. So going back on our guide, the first thing we need to do is we're going to set up SSHD to autostart. And that's done through RC update. If you look at RC-update, you can see all the various different processes that start up automatically. And then we're going to set up the clock. So the Raspberry Pi 5 has a hardware clock built in, but the Raspberry Pi 4 does not. So we're going to just go with the software clock for now. We don't have the hardware set up, and even though the Raspberry Pi 5 has an RTC module in it, it does require a battery, which is not provided when you buy the Raspberry Pi. So we're going to switch over to the software clock. And then we're going to stop the hardware clock, start up the software clock. And then, so we need to get, we need to set up the time zone. So we need ls time zone info. And you can see the various time zones available to set up here by going down this list. And specifically, if you're looking at US time zones, so to set up the US time zone, we're going to create a symbolic link to user share zone info, and this is where you choose the US/Pacific would set up Pacific time zone. And now if we do a date, actually we need to do a profile update first. For this, we'll reread the time zone settings, and then we can do a date here, and we can see the time zone. We'll notice that our time is, well, our time is way off. So we're going to pull up, let's pull up the current time. Let's see. What time is it? It is now 22:49, so we're going to set this up for 22:49, so we'll do date. So this goes by month, day, hour, minute, year. So date, January 01, 30, 10:40, we're going to set it to 10:50, which is 22:50, so we'll go to 22:50, 2025. And now if we go date, now we have the correct time set for the Pacific time zone. And we need to set the clock up so that when we do HTTPS connections, that the HTTP connection relies on the current date and time being correct. And then we're going to restart the software clock. So the way the software clock works is when you shut down the system, it writes the current date and time to a file. Then when the system starts back up, it reads that date and time from that file. And then sometime later on, it will retrieve the actual date and time off the internet. So that's how the Raspberry Pi works without actually having a hardware clock in it. Okay, so we have our date set up. We have that saved. Now we're going to do what we call, so the package manager, I think in Ubuntu, in Raspberry Pi it's apt-get. In Gentoo it's called emerge. And the emerge sync command will pull down the catalog. It's like an update command. It's going to pull down the software catalog of all the software available and put it on our system. And it's going to pull that. Well, we've got it set up. It's pointing to my dev server right now so that everything lines up and we can complete the install. Afterwards, you can switch over to the actual official one if you'd like, and run updates from there. I don't know how that's going to go. Things can break, but at least I know that this works. So we'll go with this for now. And then the next thing we need to do is, after this finishes up, it's still going, is we're going to select a profile. And the profile plays a huge role on how the software on the system is installed and how the system reacts and behaves and stuff like that. So I've got a custom profile set up for the Raspberry Pi that kind of takes into account all those different things. You'll notice that there's all these different profiles that can be chosen. So right here at the bottom, we'll see we have this GenPi64. So this is the one that we want to choose. So we will just do set profile to that. And if we do the profile list again, we'll notice that there's an asterisk next to it, meaning that it is the selected profile. Now we need to set up an option. So another part of this GenPi install is we have a meta package, as you call it, that is a package that includes other packages. And it's basically a package that really has nothing in it, but it has other package dependencies to set the system up. So we have options for that package on how you want the system installed. If you want a full install, if you want just a minimal install with no GUI. So in this case, we're going to do a full install with everything. And okay, so this is where we're going to get to use the nano editor, because we don't have VIM yet on the Raspberry Pi, because we're SSH'd into the Raspberry Pi and it has almost nothing on it. So this is nano, and we just open up the file. Notice we have etc portage package use RPI 64-bit meta here, and we're just going to copy paste this file contents into here. If you look at the bottom, we have an up arrow and an X for exit, so that means Control X. So we're going to do a Control X to exit, and save modified buffer, yes, press enter. And then we need to do one license acceptance, and I encourage you to look at the license agreement for this. It's the only thing that we need to do a license acceptance on, and it's a font package that's used in the GUI interface for IPA mana font. And in order to accept that license agreement, we basically write something to this file to accept it. Now comes the fun part. We're going to emerge the system. We're basically going to emerge and install everything on the system. And this will be, and when this finishes, we will basically have nearly everything done. We have a few settings to do after that. but this will basically install everything. There's going to be 731 packages that will be installed. Like I said, I have pre-compiled these things. I've provided the binaries, so the Raspberry Pi is going to pull down not source code, but binary packages and install them. It's going to go a lot quicker. So you'll notice that all these packages here are purple. So this is basically the summary of everything that is going to be installed. And you'll notice they're all binary installs. Except for the last one, which is our meta package, which really is just a package that has all these dependencies in it. So we're going to tell it yes here. This is going to take, depending on your internet speed, for me, and your SD card speed, for me it took about an hour. So we're going to let this thing run. I will let the screen capture go. I will speed this up, and so you guys can see the full install process. And I will come back to the video after the merge is completed and we get our command prompt back. So this, you sit back, this will take about an hour, and we'll be back then. Okay, our merge is finished. We have installed 731 packages. And okay, so now we need to do a little bit of configuration. We're getting close to done. We need to do an Xsession update. And Xsession update is, so when you install new packages, the Gentoo system will, the emerge system will set up a configuration file changes for you to review before it actually commits them, and that's what this is. So the only thing that actually has a configuration file change is the meta package, and we already set that up, so we're going to ignore it. We're going to type 1, and we're going to do a Q to quit, and then it's going to ask us, what do you want to do? And we're going to tell it to delete, update, keeping original as is. Yes. Okay. Now, okay, so I'm going to set up the editor to VIM. It's the editor that I prefer to use. You could leave the default editor to Nano if you like, but I'm going to set it up to VIM. So we'll do an eSelect editor set VIM, and that will set VIM as the default editor. And then we're going to do a we're going to reset the, re-execute the environment update and source to commit these changes so that they are valid and are, so that they, well, so the options are available in our current session that we're logged in as, so we don't have to log back in. Now we're going to merge NTP. NTP is Network Time Protocol. This will automatically synchronize our clock with the internet when the Raspberry Pi is running. So this is not included as one of the automatic installs because there are situations where people may not want to use NTP or may have a Raspberry Pi not connected to the internet, and that's why this was not included as a default option. So next, we're going to use NTPD, and we're going to immediately update the system time to the current internet time. And we can do that by, we first have to make sure NTPD is stopped, which it is, because we just installed it. We can verify it and see, and it says NTPD is already stopped. So we're going to run NTPD with the -GQ options on it, and this will automatically pull the time from the internet and set the system time accordingly. Normally you have to sudo this command, but we are logged in under the root account anyway, so none of these commands we are executing require sudo to be in front of them. Now we're going to start up NTPD. So this will, every once in a while, it will synchronize the time with the internet, and we're going to set that up to automatically start when the system boots up. Okay, so now we're going to set up sudo so that our user account, we're not going to log into the system normally under the root account, we're just doing this for setup. So we are going to set up the sudo account so that we can execute privileged commands with our normal user account. And we do that by running vi sudo, and vi sudo will open up your default editor. If it's nano, it will open up nano, but we're in vim. So we're going to scroll down to the bottom of this file, and there's an option right here that says same thing without a password. And so there's two options. You can either prompt for a password when you do a sudo command, but on the Raspberry Pi, because of the kind of embedded system that we're dealing with, I'm going to use the option that does the same thing without a password. And so we just do an I here, and backspace the two characters, escape, colon, WQ to exit, and that's saved. Now we create the user account. You can name this user account whatever you like. For this guide, we're going to use the username demo user. It's the same as the GenPi, original GenPi. And then we're going to use PASSWD to set the password for the demo user account. And for the sake of this guide, we're just going to type demo user. And that is our password. So this is the user account that we set up. And then we're going to execute the usermod command, and this will add demo account to the user group wheel. And wheel is the sudo account. So any account that's in the wheel account will be able to execute privileged commands. We're going to do that because we are now going to disable the root account so that it cannot be logged in. And we're going to do that by editing the /etc shadow file, just like we did earlier. And we are just going to delete this entire password hash out of here and replace it with an asterisk like these others. And that will effectively disable the root account so it can be logged in. You can still change to the root account, but with this asterisk in here, the root account effectively will not have a password and will not be able to be logged in using a username password anyone. We'll save that. Next, we're going to reverse what we did with SSH, and we're going to disable, we've already disabled the root account, but as another safety measure, we're going to disable, I'm sorry, I have an error on here. I will correct that. We're going to, I'll correct that on the guide before I upload it. We're going to disable the root account. We're just going to reverse what we did. See this permit root login, yes. We're going to, first of all, we're going to put the hash back in front of it. We're going to change it back prohibit password. Escape colon WQ to quit. And for the GUI, for the GUI interface, we need a few things to automatically start when the system starts up. Dbus is something essential for it. Network Manager is what's going to run in the background to manage our network connections for us. Dbus is a message bus that is required for different packages, for different modules to talk to each other. And then we have one more called Display Manager, and Display Manager is the thing that actually starts up the GUI interface and the Xorg and the Login Manager. So we're going to execute these. So this is going to set up the Raspberry Pi, so when the Raspberry Pi boots up, it will come up to a graphical user interface with a login screen, and that is our desktop manager or display manager. Now we need to tell the display manager, so the display manager and then the thing that comes up after you log in are two separate things. And you could have a login screen where you can actually choose different, I'm not sure what to call them, different things like GNOME, KD, is it, there's a few others, XC, what's the other one that we're using? Yeah, Xfce. You can add more than one of these to the login screen, so you can choose one when you log in, but we'll just go with the Xfce. So we're gonna, first of all, we need to tell the display manager what login, what we want to use, and we're going to use light DM. So light DM, and it was already installed. It was one of the packages that was automatically installed. And there's a few options. This is more of a personal preference. By default, light DM will display the last person's wallpaper as the background for the login screen. And personally, I don't like it. You don't have to change this if you don't want to, but I prefer the login screen to always look the same. So I'm going to add that option in, user background equals false. That basically tells the login manager, light DM, not to always use the same background wallpaper and not use the background wallpaper from the most recent logged in user. Took me a while to figure that one out. Okay, and then we have an example of what the file contents looks like after it's changed. Now, this next command is not really, I don't see a real change because I never got the Xsession variable to work correctly for me. We will execute it anyway just for completeness. This has to do with what the display, what session the display manager, like like Xfce, what it's going to start up after you log in. And like I said, I never got this working correctly, but we're going to do that anyway. But then we're going to turn around and delete the xsession.desktop so it does not show up as a choice in the login menu. Because if it does, you log in and then it immediately logs you back out, not starting up anything. And I have not figured out how to get around that except by just deleting that to have it default to Xfce. There's another slight bug. Not really bug, there's a slight annoyance that I fixed in the Xfce, and that is in the control panel, there's an option to change what the icons look like. And for some reason, the default choice is hidden. It's set to true, so we're going to set that to false so that if you do change the icon set, the default icon set shows up as an option, so you can change it back. I honestly don't know why it is that way, but after digging through some internet search results and stuff, I discovered this. So we will change that. Okay, now we can change the keyboard layout if we want, which we will not, but if we wanted to change the keyboard layout, we would open up this file and paste in these contents right here. And I think the default layout either matches the system or it's set to US keyboard layout. I'm not sure which one. If you do need to change it, you can change these options in here and create this file. We're not going to create this file, so I'm going to exit out without saving the file. Now the next file we need to create for sure, and this is normally on Gentoo, normally you do not have to create this file. The default options automatically work okay with the video, with the monitor and the video cards and stuff. For some reason on the Raspberry Pi it does not. So we need to help Xorg. Xorg is the GUI system that we have installed here. We need to help it and let it know what video driver settings to use in order to enable video on the Raspberry Pi. So we're going to add those options in, and some of this sets up hardware acceleration and stuff like that. I'm not 100% sure it's all working, but we'll just go with it and it at least displays stuff and it appears working. I just don't know how much hardware acceleration is actually working in the background. With that, we are actually done. So we will restart the Raspberry Pi. Now, all the options, the user account, root account's been disabled. So we're going to do a shutdown and restart, and I'm going to connect this capture device up to the Raspberry Pi, and we will see live here what happens when we start up the Raspberry Pi. So I'm going to stop the capture device right now, and I'm going to switch video over to the Raspberry Pi quickly. Okay, I'm going to restart the capture device. So we've got the Raspberry Pi up, and well, actually the Raspberry Pi is, well, I lost the screen that I had my SSH session open on. So we'll just do it from here on the console. So I'll just do a shutdown -R now. And this will shut down and restart the system. And hopefully my video capture doesn't stop between this. And if we configured and set everything up correctly, we should be presented with a login box. My video capture stopped, so I will start it again. All right, we have a login screen. So a login demo user, and we can take a quick look. I know this video is getting a little bit long, so I will try to hurry things up here. Take a quick look at what's installed here. And we have internet, we have Firefox, and like I said, there is a glitch that I've got with Chromium, but we'll try, let me open up Firefox. And this is a Raspberry Pi 5, like I said. It runs reasonably well and smooth. This is the glitch that I have with Chromium, and if anyone knows how to fix this, please let me know. I will update this and hopefully fix the problem. But whenever Chromium attempts to display any type of video object, either an ad or such, it crashes. So if we just go straight to YouTube, let's go to YouTube, and it will immediately drop to a, I honestly, I don't know what aw snap means. So if anyone knows what aw snap means, let me know. But it seems like there's either a problem with the webkit-gtk or with ffmpeg, and something's not connecting up right. So if you know how to fix that, let me know in the comments. But anyway, so I will conclude the video here. So thanks for watching. I'm going to do one more video about how to set up the Raspberry Pi without the GUI interface and just a basic install. So if you're interested in that, I will provide a link to that video in this video's description, and you can check that out. I'm going to provide this image that we just finished building available for download. I'm going to package it up and compress it, and I will do a couple things to clean out the image. I will delete the SSH host keys out of it, and let's see what else. And I will put a resize script in there. So when it compresses it down, it's going to compress down the partitions to be as small as, well, with a margin. It'll compress the size of the partitions down and compress it and make it kind of like a Raspberry Pi download image. And then the first time that you boot the image up, it'll automatically resize to fill the entire SD card. So I will put those things into the image file and make it available for download. And you're welcome to use this file as is. I recommend that you change the password or do any other things that you would like to do to have this image usable for you. So with that, I will thank everyone for watching this video, and we'll see you on the next one.